Good morning, everyone. Welcome back to another exciting day in mathematics. Warm-up 43 is on the screen. And if you notice, it's got a couple more things because we are moving on with the next concept. So make sure you are focused, please, locked in. Copy that and go road. Here we go. Being that it's Monday, I'm going to go over this really quick. Number one, graph f of x equals 1 over x. By now, you should know what to do with that. You got x, f of x, yes. Give me a second. -2, -1, 0, 1, and 2. If we substitute -2 in here, it's -1/2. If we substitute -1 there, it's -1. 0 is undefined. Next one is 1, and the last one is 1/2. So, 1, 2, -1, -2, -1, 1. So, -2, 1, -1/2. It's about right here. -1, -1. There's this side. The other side, we got 1, 1, 2, 1/2. And there's the other side. So I can get the door, please. Thank you. Number two, graph f of x equals x squared. So we got -1, 1, -2, 4, 0, 0, 1, 1, 2, 4. So that's our original f of x. But then we're going to, okay, I'll wait. You guys ready? You sure? And just a reminder, one of my pet peeves is when I'm instructing that people talk over me. That's one of them. Just FYI. So these points are what? F of x, and we're moving them in which direction? 5 to the left and 3 down. So 5 to the left, 3 down. So we end up with a graph over here. And of course we label that g of x. Number 3. Let me zoom in for number 3. Can we have negative exponents? No. This becomes 1. Oh my goodness, hold on. This becomes 1 over a to the positive 5. How did that happen, Mr. Q? Well, if I write this over 1, I do the reciprocal, and then this, when we send it to the denominator, changes to a positive value. B, any number to the 0 exponent is 1. Distribute. For C, we got 1 to the -4 power over x to the -4 power. Can we have negative exponents? No. We send this to the denominator, change this to a positive. Move this one to the numerator, upward, and it changes to a positive. And last but not least, I'm going to simplify. So, x to the 4th over 1 or x to the 4th. This is something that you're going to need because we're about to get into other functions, so make sure you are keeping up with those. Number 4, it says rewrite 2 to the x plus 5 exponent. Well, look at the example that I gave right here. X to the 3rd times x to the 5th is the same as x to the 3 plus 5, which is x to the 8th. Is that correct? So, look up. If this, if I go that way, becomes x to the 3rd times x to the 5th, what does this become if I go backwards? Talk to your neighbor. What does that become? Yeah, 2 to the x times 2 to the 5th. You guys see it? Okay. X to the 3rd plus 5 is x to the 3rd times x to the 5th. Yes? Here goes again. You guys are getting distracted. X to the third plus 5 is the same as x to the third times x to the fifth. So 2 to the x plus 5 is 2 to the x times 2 to the fifth. Kind of, sort of, yes? Yes, Mr. Q, we love these. All right, good. Number 5. By now, you guys are experts at division because we're going to need that for the next functions that are coming up. Let me check standard form. 2, 1, 0, yes. 1 and 0, yes. So let's do the division. 6x squared minus 4x plus 3 divided by x plus 2. X plus 2. All right, so what number times x gives us 6x squared? So that is 6x. 6 times x is 6x squared. 6 times 2, that's positive 12x. We're going to subtract. That means this distributes here and here. This cancels. Negative 12, negative 4, that's negative 16x. Bring down the 3. Lastly, what number times x gives me negative 16x? So that's negative 16. So negative 16x. Negative 16 times 2 is negative 32. We're going to subtract, which means we distribute here and here. This cancels. Our remainder is 35. So, what is our answer to this division? Our answer is 6x minus 16 plus 35 over x plus 2. And this is my quotient. All right, let me zoom out. Yes? Is it a what? Let me see. This is a positive one. It just like my pen just kind of like, yeah. All right, there's a warm up. We good? Yes, Mr. Q. All right. Copy the agenda. Warm up number 43 done. We're moving on today to rational functions. We're about to get into graphing and all that fun stuff. But of course, I need you guys focus. Home plate for tonight, fixed graphs for rational functions only. Now, this is being recorded, just FYI. And also, I did an update on Canvas. Some of you are still not turning in work. I don't know why, so I went ahead and put zeros on some spaces. So, after you copy the agenda, get your phones out, go to Canvas, go to our class, grades, take a screenshot, and get that signed by your parents. Bring it back tomorrow. It's going to count as a pop part tag. Also, reminder, if you need extra support, and you need extra practice, I'm here in the mornings. Come on in. I get here at 6:45 out on the street. By the time it gets me to class, I'm here at from 7:15 and on. So, start coming yourself in. All right, copy the code so access the home plate, XR7NB. Write that down, XR7NB. XR7NB. We good? All right. So, that's the home plate for tonight. Once again, if your code doesn't work, tell your neighbor where to go to get the home plate. Yeah, the YouTube channel. Bye. All right. So, before we get a Cornell note, though, get your stuff and get out the way. Yay. All right, here we go. Thank you for sending in your warm-up. Appreciate it. Our objective for today, I can solve and graph rational functions. So we're moving on, guys. Last week I gave you guys plenty of practice on long division with rational expressions and such. So we're moving on to rational functions. I can solve and graph rational functions. I can solve and graph rational functions. Get a Cornell note ready. You do need a Freyer model, Get that set up, please. So, what are rational functions? Write this in your Freyer model. Rational functions are an equation that contains one or more rational expressions. And you're saying, wait a minute, that sounds familiar, Mr. Q. Yeah, because when we covered rational equations, it was basically the same definition. Once again, rational functions are an equation that contains one or more rational expressions. Let me pause the music. Rational functions, an equation that contains one or more rational expressions. So in your brain, let's see, picture it. According to the definition, it says an equation. Tell your neighbor what an equation needs to have. Everyone. Equal sign, okay? And it says it contains one or more what? Rational expression. Tell your neighbor what that means in one word. In one word, rational expression is what? One word, Miguel. For rational expressions, one word. Fractions, that is correct. So, let's see the example. Here goes one example. Write that down. G of x equals 1 over x minus 1 plus 2. Is that an equation? Yes, I see an equal sign. Does it have a fraction? Yeah, it's right there, Mr. Q. Okay. So, students, rational functions, students. And we're going to be working with these kind from this point forward. However, let me show you some more rational functions. 2x plus 6 over x squared plus 5x plus 6 equals to 1 over x plus 3. Is this a rational function? Well, let's see. Does it have an equal sign? Yes. Does it have one or more fractions? Yes, there they are. Here goes one more. 2x minus 14 over x squared minus 15x equals to 1. Is it a rational function? Well, is it an equation? Yes. Does it have a fraction? Yes. Okay, there it is. So, students, rational functions, students. Let's look at non-examples. Look at the non-examples. Before you copy those, tell your neighbor why each of those are not rational functions. Tell your neighbor, why are those not rational functions? Tell your neighbor, why are those not rational functions? All right. Carlos, why is this one not a rational function? No equal? How about this one, Scarlett? Doesn't have an equal or a fraction. How about this one, guys? No fraction. All right. So what is so explicit about rational functions? That they need to have an equal sign or an equation and at least one fraction or one rational expression. Hashtag equation, hashtag at least one rational expression or at least one fraction. Okay, we good? All right. So now that we know what rational functions are, let me show you the steps that we're going to take today. Today, don't copy this, but this is what the process that we're going to do. We're going to identify the vertical and horizontal asymptotes. You're like, what are those? Yeah, we're going to talk about that in a little bit. Second, build an input-output table, and at the end, graph the function. Have we been building an input-output table and graphing a function? Yes, Mr. Q, thank you for the practice. Yeah, I got you. All last week we did that for rational functions. Now, reminder, look up. You guys remember this one? We're coming back to that. So tell your neighbor what K does, what H does, and what A does. Talk it over to your neighbor. What does each of those parameters do? What do they do? All right, good conversations. Let's go with Natalia Castro. Oh, sorry. What does K do? Up or down? That is correct. Positive up, negative down. Pass someone for H. Eileen? To the left if it's a what? Yes. When we substitute a negative in here, negative times a negative becomes a positive, and to the right if it's a positive. Last but not least, what does A do? Tell your neighbor, and then we're going to pass to someone. What does A do? Pass someone? Scarlett? It expands it. So yeah, so it expands or stretches like this, or compresses it like that. Stretch or compress. Okay, not bad. However, today we're going to look at it through the scope of rational functions. So copy that, please, on your notes. Copy this last one. You don't have to copy the general rule, just this last one. We got g of x equals a times f, parentheses, 1 over x minus h, close parentheses, plus k. So this is a general transformation rule, but now applying it to rational functions. Now, why do you think it's a rational function general rule? Why do you guys think? Because it has a what? A fraction. Yes, that is correct. There's a fraction right there. However, what does k do again, everyone? Up and down. How about h? Side to side. How about a? Stretch and compress. Yes? Same idea. So what's the only difference from our general rule to now this one? Tell me there. What's the only major thing that you see different? What's the only major thing that you see different? All right, Miguel, what's the only thing? What's that? Oh, help him out, Gio. Okay, aside from the fraction, what else is so obvious that's different from here to here? The one on top, that is correct. So keep this in mind. We need to make it look like that as we work through our rational functions. All right? So let's add what we talked about earlier on the steps. So look up, writing utensils down, asymptotes. We're going to be talking about asymptotes using this graph, which is rational functions. What are asymptotes? It's a line that a graph gets close to as the absolute value goes up and it increases. However, in other words, it's an invisible line that a graph will get close to but will never touch. Bam. Now, I don't know if you guys are sci-fi junkies. Any of you like Star Wars? Some of you like Star Wars? Yeah. So anyways, when you are watching Star Wars, sometimes when they shoot like laser beams and there's ships or planets that have a protection, like a shield, the ships cannot get close to that shield because it's invisible, and that's exactly what asymptotes are. And we'll get to that in a little bit. We're going to be covering three types. The first one, vertical. The next one, or horizontal. And the last one, diagonal, slant, or oblique. The last one is the one that requires a little bit more work than the first two. So, with that said, in the rule that you just wrote down on this one, I want you to label this. The H is also going to work for our vertical asymptote. Label that in blue if you have it. And the K is also going to work also for our other asymptote known as the horizontal asymptote. Horizontal meaning side to side, vertical meaning up and down. Okay, we good? All right, so get your graph paper in front of you, please. we're going to start at the top left. I want you to write example number 1 and label that identify the asymptotes. So on the side you're going to write Q f of x equals 1 over x. To the right of that you're going to write G of x equals 1 over x minus 1 plus 2. So right now, this one on the top left of your paper, this one in the middle, so you can use the coordinate plane on the right side. Just copy those, and we're going to do this one together. All right? Let's start with this one. F of x equals 1 over x. That's a parent function, Mr. Q. Yes. So question. Does it have a number after the fraction? No. Do you see anything there? No. So that means our K, or our horizontal asymptote, we're going to label that horizontal asymptote. I'm just going to write HA. And I'm going to write G of x equals to 0. Now check this out. Horizontal meaning side to side, yes? So where's G of x equal to 0? Right here. And to make sure that we indicate that it's horizontal, we go side to side, and we're going to make a broken line like this, a dotted line. Dot, 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 dot. So like that, we can imagine that it's an invisible horizontal line. Okay, so we're done with the horizontal. Let's go with a vertical. Here's a vertical. So write VA, vertical asymptote, x equals. So from now on, to find the vertical asymptote, you're going to take the denominator, set it equal to 0. And that's how you find your VA. So what is our VA? X equals to 0. So vertical meaning up and down. So let's go to x equal to 0, which is right here. So that means our vertical asymptote is going up and down like so. And that's how you graph your asymptotes. From 1 to 5, how comfortable are you with that so far? Where are we at? Yeah, 1, 2. Okay, we'll get there. 4, 5. Okay. All right. I want you to move to the next graph to the right of your paper. And on the left side, you wrote example super Q, G of x equals 1 over x minus 1 plus 2. Let me clear this up. All right. So, with that said, for this one now, let's write our VA, G of x equals. So look up, guys. Here's our general rule. Look at it. Our horizontal, our HA, HA. Our HA. By looking at this, our HA is the K, is that correct? After the parentheses. Do we have anything after the parentheses or after the fraction? Yes, the plus 2, so our G of x is positive 2. So we go to G of x equals positive 2, plot your point, and a horizontal dotted line going through that point. Next, we need a vertical asymptote, or VA, x equals. What did I ask you to do to find our VA? We take the what? Denominator and set it equal to 0. That is correct. So take this, set it equal to 0, and solve. So what do? Plus 1, x equals 1. All right, so let's go x equals 1. Here's my point, and we sketch our invisible vertical line going through that point. And those are my what? Vertical asymptotes and horizontal asymptotes. From 1 to 5, how comfortable are you with that so far? 5 fours, 2 1/2, 3s, 4s, okay? Do another one. Turn your paper over. Copy example omega q on the top left. G of x equals 1 over 2x minus 3 plus 5. Once again in red, I'm going to label, I have HA, or G of x equals. So, look up, match this one to that one, and tell your neighbor what our HA is, or our horizontal asymptote. What's our horizontal asymptote? All right? All right, tell your neighbor once again, what is our horizontal asymptote? All right, let's go with Jaime. What is it? Positive 5. Hands, do you agree with positive 5? That is correct, which is right here. So we go to positive 5 of G of x. Here it is. And sketch a dotted line going through that. All right. Next, now we need a vertical asymptote, or our VA. X equals. Remind your neighbor what to do to find our VA. What do we do to find our VA? Remind your neighbor. All right, let's go with Jacob. Go, Jacob. What do I do? Set the denominator equal to 0. 2x minus 3 equal to 0, and then we solve. So, plus 3 plus 3, 2x equals 3, divide by 2, divide by 2. X equals, what is 3 divided by 2, people? 1.5. So our VA is 1.5. Where's 1.5? About right here. And then we just sketch a dotted line going through our VA point. And that's how you sketch your asymptotes. From 1 to 5, how comfortable are you with those? 3, 4, 5, 4, 5, 4, 5. Okay. Not bad, not bad. So, let me send you a screen so you can send me your graphs. I want to see what you did. Give me a second. All right. Next. Get a new graph paper and write example 1A on the left side and then 1B on the other coordinate plane. And graph me the asymptotes for those two. Check with your neighbor. All right. So let's see. For number 1, we need a vertical asymptote, or a G of x equals, and we need a horizontal. I'm sorry. This is our HA. Sorry. I don't know why I keep doing the red and for HA. There it is. And our VA x equals. All right. So, what'd you get for our horizontal asymptote? Jacob, pass him one. Positive 2. Hands if you got positive 2 for our HA. That is correct. So it's right here. And then you should have just drawn a dotted line going through there. All right. Next, what is our VA? Pass someone. Julian. What is it? 3. Hands if you got 3. That is correct. 3 of X is right here. And again, draw your dotted line going through that. And there you go. And once again, how do we find that? Set that it equals to 0, add 3, X equals 3, and that's how we got 3. From 1 to 5, I'll come to you with that so far. 4, 5, 4, 5. Let's go with the last one. We need our HA, G of X equals, and our VA, X equals. Turn to your neighbor, let them know what each of these are. We're going to pass it to someone. All right, HA, pass someone. Geo, 4. Hands if you got 4 for our HA. Yes, so it's over here at 4. There it is. How about our VA? Turn to your neighbor, let them know what you got for the VA according to that. Then Gio's going to pass someone. Gio. Autumn. -3. Hands if you got -3. That is correct. You set it equal to 0. Subtract 9. 3x equals -9. Divide by 3. X equals -3, which is over here. And then you just get your asymptote. All right, so from 1 to 5, I'll come to write you with these. Where are we at? 4, 5, 4, 5, 3. Okay, we just need practice. All right, so now we're ready to graph 1 completely. Right now, we only graph the asymptotes. So, with that said, get a new graph paper in front of you. Copy example number, you know what? I'm going to go to example 2Q. Copy this one. Graph the function g of x equals 1 over x minus 1 plus 2. All right, so you wrote g of x equals 1 over x minus 1 plus 2. So let's do this one together. Y'all ready? Step 1, let's identify our asymptotes. So with red, we need to find our HA, or g of x, equals. And with blue, we need to find our VA, or x, equals. So let's do that first. Our HA, turn to your neighbor, let them know what our HA is for that function. What is our HA? Everyone show me with your fingers, what is our HA? Yes, 2. That is correct. Positive 2, so plot it at 2 and draw your horizontal asymptote. Next, VA. Look at it. There's a denominator. Tell your neighbor what our VA is for that one. That's our VA. Everyone, show me with your fingers our VA. Yeah, I see 1, so it's a positive 1. You set it equal to 0 and solve. Okay, so positive 1 right here. Draw your vertical asymptote. Okay, so now we're getting ready to graph this. Y'all ready? Here it goes. So, Mr. Q, how do I graph this? Well, we need a table. So first you're going to do x, g of x. Now, before you write anything else for x, writing utensils down, look up to the screen. Here it goes. So first thing, we identify our HA and our VA, yes? Second, look up please or you're going to miss it. I'm going to focus right now on our vertical asymptote. Do you guys see my vertical asymptote? All right. So now I just need to pick 2x values from the left side and 2x values from the right. So where's it going through? Positive 1 of x. Is that correct? So what would be my 2x values from the left side? 0 and what? So I'm going to start with negative 1 and 0. And 2 from the right. What 2 values should I pick from the right? 2 and 3. That is correct. 2 and 3. Now, how do we fill the g of x? Well, basically I take this, but instead of x, I'm going to substitute these values right here. So watch. 1 over blank minus 1 plus 2. So let's do this together. Here it goes. What's my first value? Negative 1. So, what is negative 1 and negative 1? What is negative 1 and negative 1? Negative 2, is that correct? Negative 2 plus 2. So, we have 2, take away 1/2, that leaves us with 1.5. Let's do it again. 1 over blank minus 1 plus 2. What's my next value? 0. What is 0 minus 1? Well, negative 1. What is 1 divided by negative 1? Negative 1. So what is 2 minus 1? 1. So let's graph those two for right now. Negative 1 of x, 1.5. 0 of x, and 1. We got that side. Let's do now the other two values so we can finish this up. Here we go. 1 over blank minus 1 plus 2. What's my next value? My next value is 2. So, on the denominator, 2 minus 1 is 1, so 1 over 1 plus 2. What is 1 over 1? Plus 2, that's 3. Okay. And let's use that for the last value. Here's a blank. Minus 1 plus 2. So my last value is a 3. So what is 3 minus 1? 2 plus 2. So 2 plus 1/2 is 2.5. Let's graph these two. 2, 3. Okay, I'll wait. We will finish this, by the way. Ready? All right, here we go. 2, 3, and 3, 2.5. 3, 2.5. And there you go. And that's our graph. That's exactly how I want those 6 graphs for tonight, people. Make sure you get all your practice in. I'll be here in the morning in case you have questions. Those of you following on YouTube, make sure you put your practice in. See you guys next time. Peace.